Welcome to Shorosa's classes. Today we are going to deal with uncertainty and consumer behavior. Let us see some examples. Question number 1. In this, we consider a lottery with 3 possible outcomes, namely $125, which has a probability of 0.2, $100, which has a probability of 0.3, and $50 with a probability of 0.5. Now we find out what is the expected value of the lottery. Expected value, which we determine here as EV of the lottery, is equal to the sum of the returns weighted by the probabilities. In this case, EV is equals to 0.2 into 125 plus 0.3 into $100 and lastly 0.5 into $50. This, after calculation, we find that it's $80. Hence, we see that the expected value is nothing but the probability multiplied with their expected outcomes. And the total expected value of this lottery is $80. Moving on. Now, we try to find the variance of the outcomes of the lottery. The variance is the sum of square deviations from the mean. We denote it by sigma square. Over here, from the previous question, we found out that the mean is $80 when weighted by their probabilities. Now we find sigma square. Hence, sigma square is equals to 0.2 into 125 minus 80 whole square plus 0.3 into 100 minus 80 whole square plus 0.5 into 50 minus 80 whole square, and this, after calculation, we find out that it comes to $975. In the next question, we would find the risk neutral person, whether he will play the lottery or not. Moving on. A risk neutral person is indifferent to or balanced with respect to a financial risk. Hence, a risk neutral person would like to pay only the value that he is gonna get from the lottery. That is, we find out the expected value of the lottery. As we see, the risk neutral person would pay the expected value of the lottery, which is equals to $80. Now, in the next question, we see that suppose you have invested in a new computer company whose profitability depends on 2 conditions that we are given with. First, whether the US Congress passes a tariff that raises the cost of Japanese computers, or second, where the US economy grows slowly or quickly. Now, we'll analyze this in 4 mutually exclusive states of the world. Now, we see 4 different stages. Stage 1. In this, we assume Congress passes tariff and there exists a slow growth rate in the US economy. Thus, there exists a slow growth rate along with a tariff. The second stage is seen when there exists a slow growth rate and the US Congress does not pass a tariff. The third state consists of the Congress passing the tariff, whereas there exists a fast growth rate. And finally, the last stage is when the economy exists with a fast growth rate and the Congress does not pass a tariff. In the third question, we are given with a problem where Richard faces the following probabilities along with the returns. It is seen that each ticket costs $1, and now we have to find the expected value of Richard's payoff if he buys a lottery ticket, as well as we will be finding out the variance in the next stage. Expected value here we denote as EV is nothing but the sum of the returns weighted by their probabilities. In simple words, we just multiply the probability with the corresponding returns. Thus, EV equals to 0.5 into $0 plus 0.25 into $1 plus 0.2 into $2 and lastly 0.05 into $7.5. This on calculation comes to 1.025. Similarly, variance is the sum of square deviations from the mean. Here we see $1.025 is weighted by the probabilities. We denote variance by sigma square. Hence, sigma square is equals to 0.5 into 0 minus 1.025 whole square plus 0.2 into 2 minus 1.025 whole square plus 0.05 into 0 minus 7.5 plus 0.25 into 1 minus 1.025 whole square. This amounts to 2,812. Now we see that Richard has been given a no risk Rick name. This means he is an extremely risk averse individual. We consider whether he will buy the ticket or not. And in an extremely risk averse individual, we see that even though the expected outcome is higher than the price, which is 1.025 is greater than $1, he will probably not buy the ticket. The reason being that the expected return is not enough to compensate risk for Rick. For example, if his wealth is $10, let's take an example. He buys a $1 ticket. He would have $9, $10 and $11. Taking a fourth possible outcome of $16.5, let's assume an utility function u equals to w to the power 0.5. where W is his wealth. Now we'll find the expected utility of this individual. Now the expected utility EU can be found out in the following manner. EU equals to 0.5 into 9 to power 0.5 plus 0.25 into 10 to power 0.25 plus 0.05 into 16.5 to the power 0.5. This can be calculated as equals to 3.157. Now suppose Richard was offered an insurance against losing any money. If he buys 1000 lottery tickets, we'll find out whether he'll be willing to pay to insure his gamble. Now, if Richard buys 1000 tickets, it is likely that he will have $1025 minus $1000 that he paid, or $25. Thus, in this case, the expected return 1025 is greater than the cost, which is $1000 only. In this case, he might not buy any insurance, but since Richard is risk averse, as stated previously, he might still want to buy an insurance. Now finally, we analyze the situation in the long run, whether the price of the lottery ticket and the probability return given in the original question, according to that, whether the state would continue with the lottery or not. In the long run, the state would be bankrupt. This is because, given the price of the ticket and the probabilities, the lottery is a money loser. The state must either raise the price of a ticket or lower the probability of positive payoffs.